Now then, it's three-phase motor time again. Running a three-phase motor from single phase, but this time it's in situations where you need extra starting torque. So you can use a pilot motor. So for that situation, as an example, we have a three-phase motor here with a big gearbox, but we can ignore that, and another three-phase motor. How many watts is that? That's about half horsepower. So what we do is we start this one with a capacitor, and then what that does is it stabilizes the third phase, and effectively, because you've got rotating electrical magnets, then it starts to generate the third phase, and then you can start the other motor. And this all comes back from years and years ago when I had a big static BTH three-phase single to three-phase converter, and it was big, sort of framed. I think there was a choke and some big transformers in there with lots of tap-ins, and you could adjust all the connections. And then there was a capacitor block, and it was literally this big. So it was a huge capacitor block. And there was fiddling, and there was notes on the inside of the cover. Weighed about 50 or 60, maybe 70 kilos. Anyway, in amongst all that lot, it said two major things, apart from all the wiring. It said, if you want a stable output, fit a pilot motor. And the second one was, if you're using a contactor with a coil, make sure the coil is across those connections that come directly from the mains, rather than the induced third phase. That way the coil pulls in cleanly. Now, in these sort of situations, if you get a contactor and the coil is buzzing and clicking in and out, just change the coil to another of the phases. Anyway, let's just have a look what's going on here, and we'll have an experiment. So what we have here, the main's coming in, and it comes in here. Live, neutral. Neutral goes off to one of the connections on the motor. Live comes along and goes to another of the connections of the motor, and also there will be a link to a capacitor, which then takes power to the third connection in the motor. There you go. So at the moment we have got 15 microfarad attached to this. Okay, ignore these bits of wires because basically they are 1, 2 and 3, which go off to a switch which then connects that second motor. Okay, and those 3 wires there are the same as connecting there, but I've just gone into the connector block. So let's just see what happens. So let's just plug this in. So that capacitance is just good enough. We've got the meter. On AC volts, and let's just measure across these. 206, 230. That is across the capacitor from live. That is across the capacitor from neutral. And there's mains voltage. We could probably get away with a slightly bigger capacitor. just to bump some of the volts up. But there we've got the pilot motor running, and this is just no capacitors, just straight connection, and it starts just like that, and it runs very smoothly. So what I want to do now is just experiment with the capacitors to try and just bump that output voltage up a little bit. If you do it too much, the pilot motor will get hot. But we could just increase a little bit. Let's just see what happens. And also you can put a capacitor between the induced phase and the neutral, so you've got one from live to the third phase and one from neutral to the third phase. That way it will increase the voltage of the third phase between the phase and neutral, if that makes any sense at all. Let's just have a go. So I've added another capacitor in parallel with that first run capacitor. It starts better, and let's just check the voltages. This is between live and neutral. Yeah, so that's mains voltage, and that is between live and the third phase. See, the voltage has gone up 264, and between neutral and the third phase is 240, which is a bit better. So now I want to add a 5 microfarad capacitor between neutral and the third phase. So just to reiterate, that's the live, and we have that and that going off to 2 capacitors and back to the third phase. This is the neutral, and we have a capacitor. Actually it's 6.9, so it's 7 microfarads from the neutral to the third phase. So let's just see how we get on. We've got the voltmeter in place. Start it up. It starts easy enough. Between neutral and the third phase is 267. 257 between live and the third phase, and there we have mains voltage 232. So let me just switch the main drive motor on. You can hear that the pilot motor is not humming so much. So let's just see what the neutral to third phase voltage is now. 226, and the live to third phase 233. So I think that's pretty good. The next thing to do is to just switch that off. I think that's pretty good. The next thing to do is to transfer this to something that needs quite a lot of torque to start. So the experiment continues.